EcoCar is a 4-year competition to convert a 2016 Chevy Camaro into a hybrid electric vehicle.
Keeping in mind all of the constraints that a real-world vehicle carries, such as customer satisfaction and real-world kind of road drivability. So
basically that means we design what kind of hybrid we want to build. If we get our Camaro in December, we'll get it. We're going to gut it, put in all our components, and then hopefully by the end of May have a working mule vehicle, which basically just means for hope that we can make the car run on the engine and transmission that we're going to be putting into it.
We have to make a road legal car that customers will accept as also a hybrid.
My department looks at modeling the dynamics of the vehicle, so predicting performance, 0 to 60 times, emissions, things like that.
I use MATLAB encoding to create an algorithm that would take an input image and distinguish where the lines were on the road from a video feed.
Before we get the vehicle, predict what the performance is going to be. We also work with the control algorithms team to develop the electronic control units for the vehicle.
You actually get to define the entire performance of the car. You can implement things like traction control, launch control. You are the one that's implementing the charge sustaining and charge depleting modes. You essentially control exactly how the vehicle is driven by the driver.
Right now, most of the equipment we're using is just desktop computers, but once we start getting all the components, we're working with electric motors, building a battery pack. So a lot of the hands-on stuff we'll be doing is crimping wires, cutting wires, soldering.
We just started getting our garage training, so we will be using mills, scroll saws, sanders, that kind of thing. We have our own machine shop.
My favorite part about being on the team is seeing the end product. I was a member when this team built the Malibu, and seeing it go from a pile of wires and scrap metal basically into a functioning vehicle that we can drive around. It's the coolest feeling you can imagine.
So as I stated previously, I'm the mechanical team lead, so I'm in charge of ensuring that all the components we're designing, such as the engine mounts, the transmission mounts, the cooling system for our engine, motor, and transmission, all are packaged correctly into the engine bay and Camaro in general, and also that the components are designed to withstand the forces that they'll be seeing. So we're doing FEA modeling and some CDF for the thermal management of the systems. I chose to work in the EcoCar Lab because I thought that this capstone was extremely real-world applicable. So some of the other capstones aren't as hands-on or aren't as real-world, where we're working on a real project, we have real deadlines, we have real goals we want to meet, and we're going to see an outcome in May. We won't just have some model on SolidWorks. We're actually going to be milling and making these parts and then installing the engine to see if they work. So you get an actual outcome from the work you put in. So some of the challenges we've been having with EcoCar is learning the new software. We use NX, which is like SolidWorks. It's a CAD modeling program, but it's different. It's what's used in the car industry, and it's a little different than what we're used to, so that's one of the big problems. The favorite part about EcoCar is the real-world applications it has. Again, we're not just doing homework, we're not just plugging in F equals MA. We're actually using NX to design parts that we then do analysis of, and then eventually we'll be milling them and putting them into the car. So you actually get an end product. You just don't have some numbers on a page or a pretty image on a screen. You have a real tangible product at the end of it, which I think is really cool.
I am a member of the low voltage team and ADAS team, which stands for Advanced Driver Assistance Systems. And low voltage is for communications and power to components.
We use some software like Microsoft Visio to draw diagrams of what we're doing, but then what we'll do is we'll print out those diagrams on large sheets of paper, and we can actually build. The reason Penn State Advanced Vehicle Team is so important is we come up with innovative designs that can actually influence automotive design and manufacturing in years to come. It's not uncommon for companies to see some ideas that we take and actually put them into use, because the end goal of this competition is to make a safe functioning vehicle, and the fact that a team like this can meet those requirements, usually industry can find some merit in what we do, so we can be innovating for the future.
I think one of the biggest challenges in a project like this is communicating cross disciplines. This is a very technical and very complex project, and there's a lot of different moving components. So my team is working on modeling, mechanical team, looking at three-dimensional modeling of the vehicle, electrical team, wiring and things like that. So working between all of our departments, communicating so that we're all on the same page, all moving forward to the same goal, and able to, in the end, build a vehicle. It's a very challenging process, and it's a lot of good experience in developing communication skills.
And what is your favorite part?
I think that would again be the hands-on experience. To work on I've never worked on a project this large before with this much impact, or anything this technically challenging. So some of the hands-on work I'm getting to do and really pushing myself on a challenging level.
Any kind of equipment that's specific to you or your part of the team or the team in general that you use that might be a little bit different, and what is its use? Will that be computer software or physical equipment?
So a lot of the equipment that my team uses right now in the development stages is all software. So we use MATLAB and Simulink to develop mathematical models of the vehicle to predict performance. Later on in the development of the control units for the vehicle, we'll be doing some software and hardware testing. One of the most interesting parts of this project is to kind of communicate between disciplines. So in order to build the vehicle, there's the electrical team, which handles all the electronic components, wiring the vehicle, hooking up the battery pack. The mechanical team is, they build the actual vehicle, they model everything in CAD beforehand. So they work pretty hand in hand with the electrical team and the actual construction of the vehicle. On the modeling side of things, my team, the modeling simulation team, works with the controls team to predict performance and also develop the control units for the vehicle.
I'm the controls lead, so I handle the integration of all the different controllers that we're placing in the vehicle. So by turning the vehicle into a hybrid, we're introducing things like a motor, and with the motor, a motor controller. Alongside those, we're introducing DC to DC converters, things like we're going to need to modify engine torque, and so all of this needs integration into the vehicle, and we handle that process through a hybrid supervisory controller, which is kind of a main controller that controls and connects all these smaller controllers together. We use that for just about everything. Simulink implements our simulations. We use Simulink alongside MotoHawk software to program our controller. And on top of that, we kind of use Simulink and MATLAB to act as our prototyping platform so that we can implement changes or test changes on the fly. So we can actually look at every single CAN message being sent by the vehicle, and CAN messages contain just about all the data that you would ever desire from a running vehicle. Things like what the engine is delivering in terms of torque, throttle, position, engine speed, motor speed, battery level, you name it. It's all on the canvas.